Hi, I am Niels, and well, it's great to be back here again at Vienna. It took some time, like 2019. I was here at the last Half-Stack conference, and it was an amazing conference. I always like Half-Stack because of the creativity and because you get to see really amazing technical solutions here and have a lot of fun. So my talk is going to be about cash registers, so no fun today. Sorry. I am the co-founder and CTO of Salon Hub, and we make software for hair salons. You know, the whole point of sale system, appointment booking system. Just look out at how happy these people are using our system. You just know we make great software. Yeah, I don't often talk about my job. I've done dozens of talks at conferences, and I don't even mention my work at all. What I usually talk about is web Bluetooth, about programming Lego cars with JavaScript. Fun stuff. Nobody wants to hear a 30-minute talk about the exciting world of hairstyling. But today is an exception. No fun stuff today, sorry. Just a lot of frustration about 1980s technology. Earlier this year, I got this email from Thomas at Google. And I am a Google developer expert, and I've spoken to him before about what we do at Salon Hub and how I am building a completely browser-based version of our cash register software. Well, it already is a web app, but what was missing is integrating all kinds of point-of-sale devices. You know, barcode scanners, receipt printers, cash drawers, payment terminal, customer displays, and we use Electron for that. But we actually want to move to a PWA. And a couple of years ago, that was not possible. But it's getting closer and closer, and it feels like all the pieces of the puzzle are coming together, thanks to Project Fugu and various hardware APIs, like Web USB and Web Serial, Web HID, and a couple more. And his question was, could we make a demo of our product that shows off these APIs? And could we do it in time for Google I/O Connect in Miami in 4 weeks' time? Yeah, so 2 weeks later, we had a fully functioning demo that was completely browser-based. And of course, it wasn't 2 weeks' work. It was years in the making, and it gave me an opportunity to open source a lot of our code. So we could scan barcodes and add products, and items are shown on the customer poll, and the receipt is visible on the display, and when we pay, we can print a paper receipt. And we went to Miami with that, and then we went to Amsterdam, and Thomas took our demo to Bangalore, and last week it was at I/O Connect in Shanghai. All in all, an amazing experience. So, who wants to see it? Yeah. Okay. Afterwards, I'll tell you how we created it. So, let's just switch over. There it is. This is our demo, and I brought all of the equipment with me. I have a barcode scanner there, I have a display, and I have a cash register, cash drawer, receipt printer combination. And I brought some products with me. So what we can do now, thanks to Project Fugu, is we can connect, I'll disconnect for a bit. We can connect to a device using Web HID. And when we do that, the barcode scanner can scan products, and they end up in the register. It's pretty underwhelming, I know. It's just a cash register. What else can we do? We have our display. It's connected right now. I can connect to that with Web Serial. And so whenever you scan something, it's not really visible from the back of the room, but right here it says the product you scanned. And then finally, if you want to pay, the cash register opens, and then a receipt is printed. And that's, that's basically all there is to it. And now you may think, well, that is quite easy. That isn't that much work, right? It's just opening a cash drawer and showing some stuff. I'll explain how we got this to work, because it is quite complicated. So let's continue. So how did we build it? Like I said, it was years in the making, and I've been playing with this technology in some way or form for the last 10 minutes, or 10 years, sorry. 10 years. So let's start with receipt printers. This is an essential part of the cash register. And nowadays, most of the receipt printers use USB, but they still sell serial port or parallel port versions, and some have are mobile, use Bluetooth, some are networked, but this one is USB. And we're going to use Web USB for that. And the API allows us to request a device with some specific filters. The user then gets a list of all the devices he can or they can choose from, and the browser then gets access to that particular device. And then you open it, you claim the interface, you transfer out some data to the endpoint. Okay, yeah, that may require some extra explanation. We're not dealing with web technology here, so it's quite a bit different from what we're normally used to. So USB devices have usually one or more interfaces, depends on the functionality. Most have one interface, but if you have, for example, have a printer and a scanner combination, it would have one interface for the printer part and one interface for the scanner part. So it's basically grouping functionality. And every interface has one or more endpoints. And an endpoint can be used to send data or receive data. So in case of a printer, you might have two endpoints, one to send the data you want to print, and one to receive, for example, status information about how much paper you still have left, stuff like that. So we claim the right interface. In this case, it's the only one. And we claim it exclusively. And that means that no other application can interfere with it while you use it. And then we send the data to the proper endpoint or payload. But now we can talk to the printer. We still have no idea what we're going to tell it. We need to learn their language first. So let's say we want to print this, a couple of lines. One line in bold text, and then we cut the receipts. And if we were to do this with a web platform, that would be really, really simple, right? Yeah, just npm install React, add some divs to the root, style one with inline CSS, and it's simple. No, okay, let's proper HTML. And okay, you could use paragraphs, but I'm using BRs and B tags. This is it. This is what we know, but that's not how printers do it. The language printers use long predate HTML. Let's travel back to 1990. Epson is launching their first receipt printer, and all receipt printers use thermal paper, but back then it used dot matrix technology. And Epson was famous for creating the first popular dot matrix printer, the MX80, in 1980. And they basically took a shortcut and they used the MX80 and miniaturized it, and they used the Escape P language from that dot matrix printer and adapted it to this printer, and they called it Escape POS, Escape POS. And that's what receipt printers have been using ever since. So we need to learn a language invented in the 80s. And the language is basically 7-bit ASCII. And with 7-bit ASCII, we have all the printable characters you would need, 26 of them, A to Z. And you get numbers and special characters. But that's not all. You also get lowercase versions of A to Z. Whoa. But what more do you need? It's the American standards code for information exchange, after all. So who else uses letters that are different from these ones? Now, we have some control characters for data transmission, like line feed, or what we nowadays commonly call a new line. So we could send this to the printer, and that will work. If we send this to the printer, it will actually print it out. But this is not what we wanted. We wanted it's not bold, and there seems to be something missing right there. Let's fix the bold part first. And we're not using tags, like HTML. We're using special escape characters that signal the printer that what follows is a command. So escape E for emphasis, and 1 to turn it on, and that makes the text bold. And escape E 0, and that turns it off again. And there are many commands for all kinds of formatting and commands for inserting things like barcodes and images, and too many things to list here and to go into detail. There's a manual. It's about this thick. Read it. Or don't. Don't. So we need to send a command for cutting the paper. It's GSV0, and that will cut the paper. But we're not done yet. We first need to initialize our printer. We forgot to do that. And by initializing, we make sure the printer is back to its default state, and we don't have the styles of the previous user of the printer interfering with what we want to do. Then we need to fix that O. It's supposed to be an O with an umlaut. 2 dots above an O. ASCII doesn't contain an O with an umlaut. So we need to go in a tangent here and talk about internationalization before Unicode. Internationalization in the 1980s, and we thought we had to, we moved on from that with Unicode, but we still have to deal with this when we talk to receipt printers. Yeah. So ASCII is just 7 bits. That means 128 different characters, and that means we have another 128 left. And for that we have code pages. We can swap out different sets of 128 characters in the upper range of the 8-bit byte. And it can be Western European, which contains the character that we want. It could be Hebrew, it could be Greek, it could be Ukrainian, which has its own code page, which is different from Russian, because Ukrainian uses a number of different characters. It could be Thai. Yeah, there are so many code pages. So many code pages. So we want code page 858, which contains our O with an umlaut. But to get that O with an umlaut, we need to look up the value in our code page. And in this case, it's a hex value of 99. And if we were to use a different code page, hex 99 would have a completely different meaning. Luckily, there is a library to do this. But unfortunately, the code pages used by printers can be pretty obscure, so it only supports a fraction of the code pages we actually need. So what are you going to do? Well, I created a library called Code Page Encoder, specifically for receipt printers, and it allows us to do things like automatic choosing the right code page and the characters that you want to print, and switching on the fly when needed. Of course, not every printer supports every code page. This is an Epson printer, a direct descendant of that first original printer, but some support less. Some support more, but use different identifiers than what Epson does. And Epson created escape POS, so why? Why? This is really, really annoying. But it's not just cheap Chinese printers that do that. So, a little bit about cache drawers. As you can see with this model, there's an integrated cache drawer. So, how do we open the cache drawer? Well, all receipt printers have a DK port, and you connect the cache drawer to that port, and you can tell the printer to send a pulse to that port that activates the solenoid in the cache drawer, and it just opens it. And with the combined printer cache drawer, it works the same way, it's just internally connected. So the cache drawer isn't really a different device, it's just a function of the receipt printer. So when I started this journey, I just wished there was somebody that created a library for this to make my life easier. And there were libraries, but mostly server-side or badly written, or PHP or Python or JavaScript, but just for Node, but not for the browser. So I created one, and you can basically forget everything I mentioned up until this point. Just install this library and do this. Just initialize, add some text, make it bold, add some text, and so on. Much easier. It can't be that simple. Yeah, no, of course not. I mentioned all printers use escape POS. Yeah, I lied. This printer doesn't support escape POS. Introducing StarPrint. It's exactly the same as escape POS, except it's completely different. Great. So instead of escape at for initializing the printer, we now use escape at can, because we can. I don't know. Escape T turns into escape DST. And escape emphasis on and off. Yeah, we just have escape emphasis now. And escape F for, well, F this? I don't know. So if you have a star printer, escape POS encoder is just completely useless. And you need something special, or specifically written for star print. But there was nothing, I couldn't find a single library for StarPrint, so of course I created a library for that. But don't use it, I'll get back to that. Now, receipt printers are a big mess. There were several points during this almost 5-year-long journey that I just wanted to give up. There are no standards, and I haven't even talked about the different methods of image encoding or barcode support that differs between models of the same manufacturer, printers that use 203 or 180 dpi. How many characters can fit on one line? 44, 42, or 35, or maybe 32. It depends. Yeah, it's a big mess. So this is how my office currently looks. I've got more receipt printers than what is considered healthy. It's starting to mess with me, and every time I go into a shop or store, I try to look for the model or make of their printer, because I'm wondering, should I get another one? If somebody says to you, you don't need another receipt printer, you already have more than enough receipt printers. Just ignore them. You don't need that kind of negativity in your life. So the result of this madness is a library called Thermal Printer Encoder. And that supports both escape-pos and starprint, and it supports all the different resolutions and code page mappings, and it's backwards compatible with escape-pos encoder. So if you want to print our original receipt, this is how we do it. And then we send the payload to the printer. Any receipt printer, starprint, or escape-pos. And as a companion to Thermal Printer Encoder, I created another library that wraps Web USB, and that allows us to simply connect to any supported printer and just print. And you don't need to worry about the details, about endpoints, about interfaces, anything. And as a companion, we also have a web serial and a web Bluetooth version that uses the same API. And that allows us to support all three protocols in our demo. It's basically, the difference is just which library is instantiated. And yeah, that's all there is to it. So now we're done with printers. We're done with escape-pos, and we're done with code pages. We can finally discuss the other devices. Customer displays. So this customer display is basically 2 lines of 20 vacuum fluorescent characters that we use to show the current item that is added to the receipt and the price. So the customer can check if the cashier added the right item for the right price. And the important question, do we need to learn another obscure language from the 80s? What language do customer displays speak? Oh yeah. They speak printer. And the next question would obviously be, why? And the reason again found in the 1980s, because computers back then usually only had one serial port. So if you had 2 devices, you needed to share that port. And to make that sharing work, you needed to have the devices work together and speak the same language. So when you initialize the printer/display, both are active. So if you print, everything is shown on the display. But you can send escape equals to turn off the printer or turn off the display. And when you turn it off, it will ignore everything it receives until the next initialization, where you can make another choice of device you want to have active. So web serial. We request a port, we open the port, and we specify the right speed. We get our writable stream for sending data to the device, and we write our payload to the stream, effectively sending it to the printer. And that's it. Well, we still have to deal with code pages, and we have to deal with escape-pos. But wait, that isn't right. Our display is connected using USB. So why are we using web serial and not web USB? It's because of the 1980s. So let's see why. We need to look at USB classes. USB defines a number of default classes. And if you have a device that uses these default classes, you don't need to install a driver. It just works, like ADC for audio, or a human input device, or HID for keyboards and mice, mass storage devices for hard drives, and many more. And we have CDC for communication, which includes ACM, which is a modern replacement for legacy serial port communication. So we still have serial communication over USB. Now, some classes have lower level APIs, like Web HID for HID, Web Serial for legacy serial devices, but also for the ACM class. And we have Web USB for all the other devices that do not fit in these standards classes. So this is why we need Web Serial, even though it's USB, and we don't use Web USB. But ACM is a replacement, and it's not fully backwards compatible. So USB to serial dongles, for example, don't use ACM. In fact, most USB serial devices don't use ACM at all. Almost nobody uses ACM. They just take their 1980 serial port device, add some extra chip, a custom serial to USB chip from FTDI or Prolific, and write a custom driver for that. And all of these devices are available in Web Serial. Now so you can use Web Serial for any type of serial port, either legacy or ACM or virtual. But it is a custom class. So in theory, you could write a Web USB implementation for it. You would be really crazy to do that. It would be completely useless, but you could. So I did. Don't use it. Don't use it. Don't use it. So serial ports. In conclusion, almost nobody uses actually legacy serial ports anymore. But some USB connected devices, you still need Web Serial. I created another library that uses Web Serial to connect to these kinds of displays and simply show some text. It will handle the code pages for you and escape pods. It will just handle it all for you. And now, our final device, the barcode scanner. And that is really, really easy. We don't need to do anything to support barcode scanners, because barcode scanners are just keyboards. So when you scan the barcode, it just literally types out the numbers of the barcode. And you could use keyboard events. Of course, you would need to figure out what belongs to the barcode and what doesn't, and where it starts and where it ends. But that could be solved. Well, maybe not perfect, but good enough. This is what we've been using for the last 10 years. But it is a barcode scanner. It is a HID device. So what if we could use Web HID to get the actual barcode instead of the keystrokes? So we request the device. In this case, it's a Honeywell scanner. So the filters are specifically for Honeywell scanners. Then we get back a list of devices, and because most HID devices are composite devices, and this barcode scanner also, because it's a keyboard, like we just said, it's also a barcode scanner. We need to figure out which of the devices is the barcode scanner part and not the keyboard part. The usage page, that is defined in the spec. It's about that thick. Then we need to tell it to turn off keyboard emulation and use plain HID reports instead, and listen for the input reports. And then whenever we scan something, we get something like this back. And then we can just parse this and extract the value of the barcode scanner. So again, you don't need to worry about any of this. There's a library for this. And I have a serial version of the library as well for serial-based barcode scanners. And that was our final device. With everything I've shown you now, you could build something similar to this. The actual cash register part of it, anybody could write that. That is just a list of items, and you count up the total. That's basically it. But now you can also add the difficult parts with just a couple of simple libraries. And we've always used web technologies for our app, but we used wrappers around it for integrating hardware. 5 years ago, we transitioned away from Adobe Air to Electron, and I wish we could have moved directly to PWAs back then, but that wasn't possible. But now all the puzzle pieces are in place, and this is just what I love about Project Fugu. It really allows us to move towards a future where we don't need Electron for application. But Project Fugu isn't just about cash registers or hardware. It's about all kinds of APIs to make the web more capable, making sure that PWAs can compete with native applications, be it on mobile or on desktop. And for us, that really works. And for you, it might do too. So thank you. Thank you for listening to me and letting me deal with all my frustrations about 1980s technology. Thanks.